Hi, it's Rob. Welcome to another AWS Hands-On tutorial. In this video, we'll build a real-time streaming application using an Amazon Kinesis data stream. Amazon Kinesis data streams work by having devices capture input and send data to an Amazon Kinesis data stream. The data stream will ingest and store the data for processing, then consumers will utilize the data to produce output. In our use case, we'll have a simple order processing system which will consist of a React application deployed to an S3 bucket, a REST API exposed via API gateway, a Lambda function which will process products and will persist and retrieve data from a DynamoDB database, and a Lambda function for processing orders. This will be our Kinesis producer. The Kinesis producer Lambda function will stream data into Kinesis data stream, which will then be consumed by two Lambda functions. The first is a Lambda shipping consumer, which will modify the inventory quantity of the items purchased in the database, and a Lambda email consumer, which will send an order confirmation email to the customer using SES. All the code for this app will be in a GitHub repo, which I'll provide a link to in the description below. The products application itself is rather trivial, as it only collects partial shipping information and allows for the selection of only one product. However, this is enough for us to use to interact with our backend. Looking at the React application, the main component we're concerned with is the homepage component. In the homepage constructor function, we have a constant which points to the API endpoint of your API gateway. We're also constructing an order which consists of the product ID, name, description, price, and quantity of the product the user wants to purchase, as well as their username and email captured from the form. When the page loads, I use a useEffect hook to call the getProducts function, which will fetch from your API gateway endpoint the data and then call the setProducts function, populating it with the product data which was returned from the API. In the form, we're then mapping over the products, which was returned from the API call, building a column with a radio button and the details of the product. When the user selects a product by clicking the radio button, the onChange event for the section will be fired, and it will call the setOrderedProduct function. The setOrderedProduct function will filter on the products, getting the product for the product ID, which was passed in as the event target's value. Then I'll call the setOrder function, populating it with a spread of the existing order data and then the order details. At the bottom of the form, there's a button which has an onClick event handler which calls the orderProduct function. The orderProduct function will make an HTTP post to the API gateway order endpoint, passing it a stringified version of the order. In the GitHub repo, in the server folder, there's a server.js file, which is a Node.js application you can use to test the React app locally. It exposes two routes, an HTTP GET on localhost 8080/products, which will return a hard-coded list of product data, and an HTTP POST request to localhost 8080/order, which will take from the React app an order object and display it to the console. To start the server, open a terminal in the project server folder, and if this is the first time running it, execute npm install to install the dependencies. Then run npm start to launch the server. Then in the React application's homepage component, change the endpoint to localhost 8080. Then jump into a terminal and launch the React app. If I open up the Developer Tools Network tab and reload the app, you'll see there was an HTTP GET request to localhost 8080 for the products, which returned an array of product data, which was used to display on the page. Now, if I fill out the form and select a product and then submit the order, we can see in the terminal that's running the Node server the order data which was posted to the server. Now, with a walkthrough of the React application out of the way, let's jump over to the AWS console and start building out our infrastructure. Now, you'll recall from our architecture diagram that our Lambda functions will be interacting with DynamoDB, Kinesis, and SES. So the first thing I want to do is create an IAM role for Lambda and attach policies for CloudWatch, DynamoDB, Kinesis, and SES. So I'll create a role and then select the policies. I'll give it a name and click Create Role to apply these policies. And now with our role created, let's jump into DynamoDB and create the database. Here I'll click Create Table, give it a name, and a partition key of product ID. Then scroll down and create the table. While this is provisioning, let's jump into SES and create an identity which will be used to send and receive emails from the SES service. For this demo, I'll only create one identity, which will be the same email used to send and receive the messages. Here I'll select email address, then enter your email address, then click Create Identity. Here you'll see a verification pending message indicating you need to go into your email and click the link sent in the email from AWS to authorize emails from SES. After you click the link, you'll be taken to the congratulations page, and now if you jump back in SES and refresh, you'll see that the identity status is verified. Now I'll jump into Kinesis and create a data stream. I'll give it a name, click Provisioned, and set the provision shards capacity to 2. Then scroll down and create the data stream. Now I could jump over into Lambda and start building out my Lambda functions. And I'll start with the products API. So I'll click Create Function, give the function a name. I'll use Node.js 16, and then change the default execution role to use the Lambda role I created earlier. Then I'll create the function. Now, before I add the code, let's jump over to API Gateway and create a REST API. I'll select New API, give it a name, and leave it as a regional endpoint. Now in the root, I want to add a resource, which will be the products endpoint, and enable cores. Then on products, I'll create a method, which will be a get, using Lambda proxy integration, pointing to the products API. Then on the root, I'll create another resource for product, enable cores again, then add a method to post a new product. Then I'll click Actions and deploy the API, giving it a new stage name of prod. And now we have the root endpoint we can use in our React application to interact with the API. So I'll copy this, jump back into the homepage component, and add the endpoint. In the GitHub repo, in the backend folder, you'll find JavaScript files for the Lambda functions. Here, we're looking at the Lambda function for the product API. I started by requiring the AWS SDK and setting the region configuration to US East 1. And then creating a new Dynamo database instance and setting the table name equal to the name I used when I created the table. Then I'm adding constants for the two routes, the get endpoint to list all products and the post endpoint to add a new product. In the handler function, I start by logging the event in the event body, which we can see in CloudWatch, then create a variable for the response. I have a switch statement with a case looking for a GET request to the products route, which will return the result of an asynchronous call to the getProducts function. GetProducts creates a params object specifying the table name, and then calls a scanTable function passing the parameters and an empty array. The scanTable function will make an asynchronous call to scan the database, and then I'm storing the items that are returned by concatenating them into the products array which was passed in. Here I'll make sure that all the data that's returned is processed and then return the products. I'll log the products to the console that we could see in CloudWatch, then create the body which is an object containing the products. And finally, send the response back by stringifying the body. Back in the handler, I have another case statement that looks for a post request to the product route. When this comes in, I'll call the saveProduct function, passing it the parsed event body. SaveProduct will create a params object pointing to the DynamoDB table and the requested item. Here, I'll execute a put on DynamoDB, creating a constant for the body, and then returning the result. With this code written, I'll copy it and jump back into Lambda and replace the default code, then deploy the changes. Now, with the Lambda function deployed and sitting behind the API gateway, I could jump into Postman, run a quick test to post to the product endpoint, passing JSON data for a new product. So if I click send, we see we get a status 200 response code back and that our save was successful. So now if we jump into DynamoDB, go into our table, and explore table items, we see our new product. So let's jump back into Postman, add the second product, and then a third. Now let's just jump back into DynamoDB, refresh, and we see our 3 products. Now back in Postman, if we do a GET request to the products endpoint, we get our list of products returned. And if we jump back over into the Lambda function, click on the Monitor tab, and then View Logs in CloudWatch, click on our log stream, and we see the results of our requests. If we open up the last one, we see the products being returned in the GET request. And now with the Lambda Products API written, we could jump back into VS Code and take a look at the Lambda order producer. For the producer, I've once again required the AWS SDK and set the region to USD1. I've created a constant for a Kinesis object, and then in the handler, I'll log the event to the console, and then making an asynchronous call to the stream to Kinesis function, passing it the parsed body. In stream to Kinesis, I'll create a constant for the params, which will set the data equal to the payload, the partition key equal to the product ID sent in the payload, and convert it to a string, and then set the stream name. Then I'll call the putRecord method on Kinesis, passing it the params, then logging the response to the console. So now we could jump back into Lambda console and create a new function for the producer. Again, it'll be Node.js 16, and I'll change the default execution role to use our Lambda role, and then create the function. Now I'll copy the code from VS Code, paste it into the Lambda function, and deploy the change. Now I'll jump back over to API Gateway, and in the root of our API, I'll create a new resource for an order. Enable CORS, then create a new method, which will be a post. Enable proxy integration, and then select the order producer Lambda function. And then deploy the API. Then back in Postman, we could run a quick test with a post to the order API, passing it the data for an order. Then if we go back to our Lambda function, into Monitor, go into CloudWatch, click on the log stream, and here we see the post request coming in, and then it was successfully processed in this shard ID with this sequence number. So if I copy the sequence number and jump into Kinesis, if I go into Data Viewer, choose a shard, and pick the shard that was displayed in the console output, at the sequence number, and paste in the sequence number, click Get Records, and we see our data that was streamed to Kinesis. Now, jumping back into VS Code, we could look at the email consumer Lambda function. course, I've required the SDK and set the region USD1. And then I'm creating a constant, which is a new instance of an SES object. In the handler, I'll write the event to the console and then create a variable to hold the data object. I'll loop through the records, pass in the event records, parsing the data from Kinesis and putting it into the data object, and then write the data to the console. Then I'll create a params object, setting the destination equal to the email address that came in on the data. I'll set the subject in the body, and then set the source equal to the same email address. Now, the reason that I'm doing this is because you remember in SES, I only verified one email address just for this demo. So for this to work with that email address, you'll want to set the to address and the source address equal to the email address you verified in SES. Finally, we'll make an asynchronous call to send the email to SES, passing the params, and then logging the response to the console. So now I'll jump back into Lambda and create a new function for the email consumer. Then I'll jump back into VS Code, copy the code, paste it in, and be sure to update your email addresses before you deploy. Now what we want to do is click on Add Trigger and add a trigger from Kinesis, selecting our data stream. Now if we go back to Postman and run the test again, jump back into Lambda, go into Monitor, and view the logs. If we go into the log stream, we see we received a record from Kinesis with the sequence number. We logged the data that was passed and then completed the processing. And now if I jump into my email, we see my order confirmation email was received. Now back in VS Code, if we look at the shipping consumer, I'll start out by simply logging the event to the console. Then I'll process the data sent in from Kinesis, extract the product ID from the data, and write that to the console. So let's jump over to Lambda, create a new function for the shipping consumer. I'll grab the code from VS Code, paste it in, deploy it, and add a trigger for our Kinesis data stream. Now let's jump back into Postman, test again, go into Monitor, CloudWatch Logs, then into the log stream. We see our record from Kinesis, the data that was sent in, and then the product ID. And now if we jump back into VS Code and uncomment the rest of the code, here I'll declare a variable for updated quantity, which will get the current quantity from the data that was passed in and subtract 1. Then I'll create a params object pointing to the table name. The key will be the product ID, and we'll set the value equal to the updated quantity. Then I'll execute an update on the table and return the result. So if we copy this, go back to Lambda, update the code, and deploy it, then jump back into Postman and run a test, go into CloudWatch Logs, into the log stream. Again, we see our data was passed in from Kinesis, and we have the product ID. So now if we jump over to DynamoDB, go into the table, explore the items, we see the quantity for our product 101 has been decremented by 1. Now, the last step in the process is for us to create an S3 bucket and deploy the React app. First, remember to go into the React's homepage component and update your API endpoint to point to your API gateway endpoint. Now, I'll go ahead and create a bucket. I'll give it a name, then scroll down and create. Now, I'll jump into the bucket, go to permissions, and allow public access. And I'll edit the bucket policy and add a policy that allows get object access to to all objects in the bucket. Then I'll jump into Properties, scroll to the bottom, and enable Static Website Hosting. Now, in a terminal, inside of the client folder for my app, I'll execute npm run build to build the React application for deployment to S3. And now you can see we have a build folder. Now we can go back to S3, jump in our bucket, and upload the contents of the build folder. Now if we go into Properties and scroll to the bottom, we can access the website via the Static Website Hosting's endpoint. And we see our list of products returned from our API. So that concludes this video on building a real-time streaming application using Amazon Kinesis data stream. If you found this content useful, feel free to give it a like. And if you'd like to be notified when I add new content, please consider subscribing to the channel. Thanks for watching.